Hey there. Today we're going to talk about various surfaces in 3 dimensions. So let's first talk about probably the simplest surface in 3 dimensions, which is something that looks like y is equal to 2. And this will motivate some of the things that are coming next. So when y equals 2, what we can do is we can draw our x, y, z planes and say, okay, walk out 2 steps in the y direction. And then if we're setting y is equal to 2, x can be anything and z can be anything. And so that lets us go as far as we want in the x direction, as far as we want in the z direction, and basically that turns into a plane that is parallel to the xz plane. So when we see an equation like y is equal to 2, the thing you should notice is that so x and z are not involved in the equation, so they can be anything. Okay, and so that's going to be a recurring theme here when we're talking about cylinders. I don't really like this name cylinders, but that's the name the book gives it. The idea of a cylinder is that we have a surface where all of the slices are the same. So we're going to be looking at this here. We have something where all the slices are exactly the same, and this looks like a cylinder. So that's where this name of what a cylinder is comes from. So let's look at an example. We have z is equal to x squared. Okay, so just like before, there's y. We're missing a variable. Y is not in this equation, so y can be anything. So let's draw a picture. We have the x and then the z coordinates. And if we're just looking at x and z, and we look at what happens when y is equal to 0, then we have a picture, z is equal to x squared. So we have this equation where z is equal to x squared. There's no, so when y is equal to 0, it looks like that. When y is equal to 1, it looks like that. When y is equal to 2, it looks like that. And really when y is equal to anything, it looks like that. And so what we get is we get this like a half pipe looking thing. If we were in, if we're going to go surfing or snowboarding at the snow park, we get this thing that it opens up, and you can see this sort of like a half pipe type of shape. And what it is that every slice looks like this parabola, but it ends up being a long tube because y can be anything, and so we just take whatever that shape is in the xz plane and we extend it. All right, and so now let's look at this one. Y squared plus z squared is equal to 1. In this example, we have no x. So there's no x, so x can be anything. All right, and since x can be anything, let's first draw in the yz plane and then extend that drawing towards the positive and negative x-axes. Okay, so we look at y squared plus z squared equals 1. So what do we have? We have the x, y, z. So now we have to think about this. So we can, if you aren't 100% sure what this looks like, you'd probably be more comfortable thinking about x squared plus y squared is equal to 1. And hopefully you think of this and you think, oh, circle. So if this is, we think of maybe the x-axis, and we think of this as the y-axis, we would be able to draw the circle in the yz plane. Right? So instead of being in the xy plane, this is now in the yz plane. And now we want to extend this in the positive x direction and the negative x direction, and this ends up being one long cylinder that if you were to look directly from the x-axis, you would see directly through it. Let's see how to draw those in Mathematica. So let's go over here. So the easiest way to draw these is using the contour plot 3D function, where we're specifying that we want z to be x squared. So the example that we had, z is equal to x squared, if we put this in the orientation that we're used to seeing for the x, y, and z axes, this is the x direction, this is the y direction, this is the z direction, then this is our shape that we drew earlier. This is z is equal to x squared. And then here we have y squared plus z squared equals 1. If we look in directly from the x-axis, you can see it looks like a circle, and extending that circle in the positive x-axis and the negative x-axis gives us this long tube. So the takeaway message is, if you see an equation that's missing a variable, then you have this idea that's they call a cylinder, many copies of the same function extended in both directions. All right, see you soon.